Here you see a piece of 3-inch tubing laid out on a piece of paper for a 90-degree miter. I'm going to walk you through how to make a template so you can lay it out on a piece of pipe or tubing as shown and transfer it for cutting. So I'm just going to take a quick measurement on this piece of tubing to make sure I have the exact measurements correctly. And now I'm going to draw on the paper 1/2 of this mitered joint in this pipe. Again, you can see it's 3-inch. I'm drawing 1/2 of the 90-degree miter. So now I'll lay it out on a piece of paper and we'll commence to make a template. Using a compass, I've drawn a half circle on the bottom of my pipe design to simulate half of the circle of the pipe. Now I'm going to divide that half circle into 8 equal parts. I'll start by going right up the middle. Then I'm going to continue that line straight up 90 degrees from the bottom line straight on up to intersect that whole drawing. Now again, using my compass, I'm going to divide that half circle into equal parts. Again, you can see I'm just doing a bisecting line using my compass. And from there, that'll give me points to be able to start dividing that half circle up. I like to use a 0.5 millimeter drawing pencil. It gives you a nice, crisp lines. The nicer you can keep, the cleaner you can keep this whole thing, the better your finished product's going to be. Now again, so now I've got 4 equal parts. Now I'm going to divide those again by swinging little bisecting arcs off of there. And now I'll be able to divide those and give me 8 equal parts. And now that I've got my bisecting marks laid out, I'm going to finish dividing that half circle into 8 equal parts. Now with these 8 equal parts, I'm going to give each line in there a number, 1, 2, 3, 4, 5, etc. Now using those equal divided points, I'm going to draw a line straight up from each one of those points where it intersects the circle, straight up to the top of my miter joint. You can see I'm locating that down there, and using a piece of gridded graph paper, which has all my lines parallel and perpendicular, saves you a lot of work. I'm transferring those lines straight up the pattern to the top of that miter cut. All my lines are transferred up to that miter joint. I'm going to give those transfer those numbers up there, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like the numbers correspond down on the half circle. So here's part of the early design all completed. You can see I've got a half circle there. The numbers are corresponding to the numbers down on the half circle. I've drawn those lines straight up to start my template. Adjacent to my first part of my drawing, I'm going to draw a line probably 10-12 inches long, and I'm going to start transferring those measurements of that segmented circle over onto this line I've drawn. You notice my compass is set to the exact length of each one of those segments. All those segments are equally divided on that circle. Each one is the same length. What I'm doing is replicating. If you took a circle and you divided it into a bunch of equal parts, now I'm replicating that on a straight line, as though if you took a pipe and cut it down the middle and roll it out flat. That's what I'm trying to simulate here. First time you see this done, it's kind of confusing. If you follow along and just copycat what I'm doing here, it will start making a lot more sense to you. So I have 16 equally divided segments. I'm going to make 16 equally divided points on this piece of paper. And I'm going to transfer those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just like it's done on that piece of paper. If done correctly, the length of these layout marks should equal the length of the circumference of your pipe. In other words, the full distance all the way around that pipe. Taking 3 times 3.14 gives me approximately 9 3/8 of an inch. Quick recap, I've taken one of those segments from that divided circle and laid it out on a line. This number again corresponds, if this was a complete circle here, we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then if we took this pipe and we cut it and we roll it out flat, that's what we'd have right here. The same length here is the circumference of that pipe. So now I need to transfer some lines. I'm going to draw some lines straight up the run here. They don't have to be exactly right. Now I'm just going to run them kind of wild all the way through. I just want to make sure they're square, this line here. That's why this blue fade out graph paper is fantastic, because I don't need to have a square handy to draw each line. I can just follow these little lines. I know they're extremely hard to see when you're viewing this on the YouTube, but they're there. If you go down to a drafting store, art supply store, an office supply store, they will generally almost always carry this graph paper. It's called fade out line. A lot of people are drafting with AutoCAD now, including myself, but at times I still got out my pencils and rulers and graph paper for things like this. A pipe fitter can go out and buy templates. To get a template for every size you're going to need, you could spend hundreds of dollars on. There's a couple of good programs out now, computer programs. You can plug your angles in and whatnot, and it'll spit out a template for you. But if you want to do things old school, you don't have the computer handy with the program, you can do this. Okay, so I've drawn a bunch of lines here. Now I'm going to transfer these lines. This was a piece of pipe. I'm going to start transferring these corresponding lines here. So there's my number 1 there. So every place I have a number 1 here, I'm going to transfer that length to it. And so forth. Now number 2. We're on this number 2. Number 3. I had to order this compass online. The local drafting store didn't have it. The local, artist supply store had them, but they were kind of small and funky. This is a large one, very nice. I can go up to about 24 inches diameter. So I'm on number 5. I go to 5. Anyway, I can go up really large here. It's super accurate, super nice one. And I've stuck an actual drafting pencil in here instead of a regular pencil. I can keep a sharper point on it, or I can just push the button and get a longer lead there if I need it. Again, 6 and 6. I'm on my line number 7. A couple ago, and I've got pretty much my template completely made here. Number 8 and number 8. And my last point, which is my longest point, corresponding to this template, number 9. So there would be the top of my plate. Now I need to connect all these lines. A little bit of freehand work here. This type of template is line development, and you can use it for sheet metal work. In other words, boots, transitions, and any pipe fitter or fabricator. It's a really handy thing to know. I'll get into some more videos later on that are a little more complicated than this. If you want to do, saddles for pipe, like let's say you have a 12-inch pipe and you want to bring a 6-inch saddle into it, how to make those templates. This is probably one of the easier to make, but it's the same type of thing. You lay out everything on paper. And I'm going to cut this out right here like so. You can still see our numbers. And finally, a little more here. I will cut out these now. This template can be wrapped around your pipe, and you can trace that template with a marker pen on your pipe. Oftentimes it's very nice to take a punch and punch a little divot in this template along it every so often, ½ inch or something, because when you're cutting with a torch or plasma cutter, your mark from your felt pen or whatever you use can disintegrate, but you'll always be able to see your little punch marks. Okay. Again, here's a brief recap of what we've laid out and everything except I've connected the lines on my template here. Okay, now I'm going to take my template. I'm going to wrap it around this, but I'm going to secure it someplace with a little piece of tape here. Now, if everything went right, this thing should meet right together. So I'm going to secure it with a piece of tape. See that? It's within probably a 32nd of an inch there. Now you can take a felt pen, trace the top of that template, and transfer a mark onto your pipe, and you're ready to cut. So I've drawn my line all the way around my pipe. I can remove my template. In fact, it's nice to take this template and trace it on some heavier paper and roll it up, put it in your an electrode rod holder, carry it around the job site. So there you are. I'm going to connect this up here. Now I have a complete mark for a cut. As you will see, there's a 45. Looks like from the front. And you can use this layout for pipe cutting and or sheet metal work. This is tubing. Happens to be stainless steel tubing. If this was heavy wall pipe, then you really got to pay attention to what angle you're cutting, making your cut on. So by the time you're done, you're not doing a whole heck of a lot of grinding to make it fit perfectly. And this procedure for laying out templates can be used on any pipe from 1 inch up to 48 inches. Again, obviously you have to have a long piece of paper to lay out something 48 inches. But anyway, you can use this design for any kind of miter corner, whether it's 45 or a 90 or a 22.5, same principle. Thank you.